Week 1, Lesson 10. Okay, so example says, a parallelogram exists with points at, so let's go ahead and graph, -2, -1, this is point A, 3, 0, that would be point B, and D at 0, 2. Okay, and it says find the location of C using vectors. Okay, no problem. Now, I want you to remember back to geometry where shapes are always named in either clockwise or counterclockwise order, all right? So since we have A to B, and then somewhere over here there should be C, there's only one possible location for C. It's got to be up here in this general area, okay? But I want you to recognize, and let me erase some stuff and see if this makes sense to you, and then I'll relabel it. If I didn't know the names of these points, and I said find the fourth point to make this a parallelogram, then there would be 3 different locations, right? I could have a dot up here somewhere, or I could have a dot down here somewhere, or I could have a dot over here somewhere, right? Any one of those would make a parallelogram. So I want to make sure that you are aware that only, oh, that's not an eraser. The only reason, I can't get rid of those dots. Crap. Hold on. Oh, there we go, different eraser. Okay. The only reason that, that's the wrong color. The only reason that I am putting C in this general area is because it says that it's a parallelogram and I know the names of those points. Okay. Now, I know that you could probably just go ahead and count it over. If you decide to do that on a test or quiz or final or whatever, I'm going to mark it wrong because it very, very clearly says that you have to use vectors. So I want you to see that vector AD has to be congruent to BC, all right? And again, I don't know where C is. C is just some ordered pair that I'm going to call XY, but it should be congruent to BC. All right, so let's figure out what AD and BC are by doing head minus tail. Okay, so head minus tail, so D minus A. So D in the X direction minus A would be +2. And 2 minus -1, again, going in the same direction, means that vector AD could be named as 2, 3. Which, again, if you just like look really close, right, I think you'll agree it's 2 to the right and 3 up. Okay, but I wanted you to see that whole head minus tail thing because that's what I'm going to have to do BC. C has this ordered pair and B has this ordered pair. So when I do head minus tail, I get X minus 3 and Y minus 0. Now, if you look really close, I actually have now 2 equations to solve. I've got this one highlighted in blue and this one highlighted in yellow. So if 2 is equal to X minus 3, X equals 5. And if 3 is equal to Y minus 0, then Y equals 3. So I think the ordered pair is 5, 3. And if you graph it, 3, 4, 5, 1, 2, 3, look at that. It's right there. And you can see the parallelogram. Okay, let's try the other one. So now we're going to move into 3 dimensions. Okay, so this picture is of something called a parallelepiped. Okay, it's called that because our book is from Europe. So here in the States, we probably would just call that a 3-dimensional prism. But because one of the faces is a parallelogram and then it becomes 3-dimensional, they're calling it a parallelepiped. Okay, I would like you to note, based on what's given here, that we know 3 ordered triples. We know A, we know B, we know D, and we know E. Okay, those are the 4 ordered triples that we know. Okay, so, and they want us to find C, so I would like to find, and I'm going to do this one at a time. I'm going to find this one first. Okay, and I'm going to use the same logic that I just did on the last one, which is that AD should be congruent to BC, right? They are parallel, they are going in the same direction, they have the exact same magnitude. It literally is the same flippin' vector, right? The only thing I don't know is what this ordered triple is. But that's okay. I'm going to solve this. All right, so AD, if I do head minus tail, right? So I do these ordered pairs, ordered triples, minus these ordered triples. Oh, look how convenient that is. When I subtract, I get vector AD, right? And then vector BC, and again, I don't know C. I'm going to use these variables, but I do know B. B is this ordered triple. So x minus 2, y minus 3, and z minus 0. And as long as I can solve for x, y, and z, I will have the location of point C. Okay, so C ends up being 1, x ends up being 1, y ends up being 7, and z is negative 2. And again, I will leave that solving to you. I think that you can solve this and this and this. Okay, so now that I know that, and I'm now asked to find point G. So G is up here. And now I'm going to call G x, y, and z. So I just need to figure out a couple of vectors that are equivalent. And I'm looking, and I think since I know this vector, AE, that will be congruent to that vector, CG. All right, and again, to name those vectors, you've got to do head minus tail. So for AE, if you do E as the head and A as the tail, you end up with this. All right, likewise with CG, if G is the head and C is the tail, I'm going to have x minus 1, y minus 7, and z plus 2. And then you just have to solve. Again, there are 3 respective equations to solve here, right? Solving those 3, you will get a point G of 2, 5, and 4.